Hello and welcome to another tutorial on RDS Analyst. I'm Ian Fellows, and today we're going to be talking about performing population frequency analysis. So what I've done first is I've loaded in a data set called FOTime, which is a synthetic data set with network size and a categorical variable here. And also it has, as part of its RDS recruitment, date interview. So it has the actual interview date for each individual, and we can see that right here. What that allows us to do is it gives us access to another frequency estimate that isn't available if that variable is not present. Namely, if we go to population frequencies, we see that for the FOTime we have an estimator called HCG, Homophily Configuration Graph. And this is a model-based estimator for RDS analyses. And it's sort of a generalization of the RDS1 estimator. It actually reduces to the RDS1 estimator in the case of large sample fractions. Additionally, we have the Giles SS estimator, which is a generalization of the RDS2 estimators and reduces to the RDS2 in the case of large or small sample fractions. RDS1 and RDS1 data smoothed are two additional estimators, and then RDS2. RDS1 is sometimes known as the Fulgonic hectophoton estimator, and what we can do is perform an analysis. We're going to go ahead and perform an analysis with the HCG estimator. Now, each one of these estimators is associated with a bootstrap procedure, and that is what allows us to get uncertainty estimates around our parameter estimates. So we're going to do frequencies on var1 using the HCG estimate. We're going to want 95% confidence intervals, and we're going to do 500 bootstrap resamplings. Our population size, which is required for HCG, is 3,000, and we can go ahead and run this analysis. Now, performing with bootstrap resampling does take a few minutes. And we start to see some progress being made here, 10% complete with the bootstraps. And here we see that the bootstrap has completed, 100% complete, and we get a table of results out from it. We see that it has two levels, 0 and 1, and the point estimate here is 0.85, 85% in the 0 and 14.69% in the 1 category. We also get confidence bounds and the estimated design effect. Now, the design effect is the estimated amount of variance inflation, the size of the bounds being inflated due to the design effect of RDS. So what we estimate here is that we'd have to collect about twice as many people in this design in order to get the same specificity as if we were doing a simple random sample of this population. But of course, we use RDS in cases where simple random samples are not typically possible. Also, we get standard errors and sample sizes out of this.